Okay, so this video is going to show us how to run a factorial ANOVA or two-way ANOVA. The data file that I'm using is SPSS for YouTube dot save SPSS file. A factorial ANOVA or two-way ANOVA allows us to test if there are significant differences based on two main effects, and also the interaction of those two main effects, and if there are significant differences based on based on that interaction. In order to run a factorial ANOVA or two-way ANOVA, we select Analyze from the pull-down menu at the top. We go to the fourth one, which is General Linear Model. Another menu pops up. We select Univariate. The univariate dialog box appears. So we have to tell the computer what our dependent variable is and what our fixed factors are, which would be our two main effects. So in this case, we're going to use the grade 11 language arts literacy scale score as our dependent variable, and we're going to see if there are significant differences based on the years a student is in the tutoring program and based on the school. So we simply select those variables from the left-hand side and put them in our fixed factors box. First thing we need to do is we need to select the plots button, and this is going to allow us to check for the interaction. So we have to place a variable in the separate lines in the horizontal axis. Typically, choosing which variable to put in here, usually the variable that has more levels to it, for example, in this case, years tutoring, it'll have 0 years, 1 year, and 2 years, 3 levels, we're going to put as separate lines. And the variable that has the least amount of levels, in this case, school, there's only 2 schools, school A and school B, we're going to put as horizontal axis. Once we have both of them in place, we click the Add button, and you'll notice that both of them will appear down here in the plots box with a little asterisk behind it. So this is telling SPSS it's going to check for interaction between our two main effects, between school and between years and tutoring. We click Continue. Now, since years and tutoring has 3 levels to it, we can select the post hoc button and take the years and tutoring, put it in the post hoc test window, and you'll notice these all become active, and select Tukey. And the reason we can do that is because the years and tutoring has 3 levels. If both our main effects variables only had 2 levels, we wouldn't really be able to do this because post hoc is for 3 or more levels. We click Continue, and then the next thing we want to click on is the Options button. For the Options button, we want to take all of our variables over here, the years and tutoring main effect, school main effect, and years and tutoring school interaction, and we want to put them in the display means box. So we simply select these, put them over in our box, and then we're going to compare the main effects. Confidence interval adjustment LSD none should be selected. There are other selections, but we want LSD none. Then we're going to go down to our display box down here. We're going to select homogeneity tests, which would be the Levine test, the observed power, estimates of effect size, and descriptive statistics. Click Continue. We click OK, and we get our factorial ANOVA or univariate analysis of variance. The between subjects factors tells us our N for each of our categories. So years in tutoring is 39 students. Years in tutoring program 1 year 68 and 2 years 107. School A is 70 students. School B is 144 students. We get descriptive statistics broken down by years in tutoring and the school. This will be important later on when you want to take a look at the plot and take a look at what may be happening as far as the interaction of the two main effects. Our Levine's test, homogeneity of variance, is almost significant. 0.053 is not quite significant, but it's almost significant. So this could actually create an issue a little bit later on. We come to our most important table, and that's our test of between subjects, or our actual two-way ANOVA, our factorial ANOVA. You'll see it has both our main effects, years in tutoring, school, and then years in tutoring, school interaction. So let's take a look at years in tutoring, and we see that this is significant. So what it's saying is that there are significant differences based on the number of years a student is in tutoring on the grade 11 language arts test. There's also a significant difference based on school. So both main effects are significantly different. However, our interaction term between years in tutoring and school is not significantly different. Although it's close, 0.056 is close, it is not significantly different. However, I would assume that our profile plots might not be ordinal in this case because significance is close. It's potential that it might be disordinal. When we scroll down, we take a look at our mean plots, 228 for years in the program. We take a look at our pairwise comparisons. Years in the program to 1, years in the program to 2 is significantly different, but not 1 to 2. The univariate test is significant, meaning years in the program is statistically significant. When we take a look at school, school A's mean was 233, school B's was 239. That 5 point, almost 6 point difference is statistically significant. So school B is outperforming school A. Here's our years in the tutoring program again by school and the years in the tutoring program. So you'll notice school A, from 1 year to 2 year, there was a slight decrease. You'll notice with school B, there was a continued increase from no years to 1 year to 2 years. Our Tukey's post hoc actually just verifies our pairwise comparison before for years in the tutoring program. 0 to 1 is significantly different. 0 to 2 is significantly different. 1 to 2 is not significantly different. We take a look at our profile plots, and as I said before, normally you would consider this as disordinal profile plot because lines are crossing. However, if you remember, there was not significant interaction, but we were close. So it's potential that if we had a larger sample size from possibly one school to the other school, we might find significance, we might not. This really just tells us at this point in time that we really don't know if there's a significant interaction. Closer look would need to be taken. Based on this, students in school A and school B for 1 year basically scored the same. There was a slight increase for students in the program for 2 years from school A to school B. But the big difference here is school A to school B, no years in the program. No years in the program for both from school A to school B. This seems to be quite large difference. However, it wasn't considered statistically significant as far as the interaction is concerned. So that's a factorial ANOVA, and in this case what we could basically say is that yes, years in the tutoring program does tend to make a difference for students. As a matter of fact, as the years in the tutoring program increase, the students' LAL score tends to increase, and school makes a difference. We might want to take a closer look at what those differences are between schools to see what possibly might be going on.